Hi, in this video we are going to try to look at the circuit here. We've been given a voltage and there are some components connected here and we need to find out the current. Now to find out this current, basically what we need to do is we need to find out the equivalent impedance of the circuit to the right of this blue line that I'm drawing, right? So we'll do that. Now to do that, let's convert first of all into the phasor domain or into the frequency domain. Now the first thing that we want to do is, if we want to do that, is to convert the capacitance into an impedance and the inductance into an impedance. Now we know that the capacitance, the impedance of a capacitor is given by 1 over j omega c. We looked at that in the previous few slides. Now what is omega in this case? From here, from the input, we know that omega is equal to 3000, right? So you can substitute the values of omega and of c in this formula here. Substitute the value of omega and substitute the value of c, and you should be able to get minus j 2 kilo ohms. Okay, similarly you can calculate the impedance of the inductor, and that's going to be given by j omega l, and that becomes 1 kilo ohm. Of course, j times 1 kilo ohm, or you could just say j kilo ohms, right, instead of j plus 1. So let me just write it as j kilo ohms. Okay, so we can redraw this circuit in the phasor notation, and what we get is you have voltage source here and the amplitude of the voltage source is 40, and what's the phase? Now you may be mistaken and you may say the phase is 0, but that wouldn't be right, because here we have a sine and not a cos, right? And therefore the phase is going to be, because we have to measure the phase, let's just as a principle in all our circuit design, let's just assume that we are measuring the phase with respect to a cos signal, and the cos signal has 0 phase. Okay, so here then we can write this as minus 90 degrees because that's a sine wave. Okay, and then we can draw our two resistors, and then you have your capacitor here, your inductor here, and the impedance of this capacitor becomes minus j 2 kilo ohms. This is 1 kilo ohm, this is j kilo ohms, and that's 1.5 kilo ohms. Okay, and we need to find out IT, but to find out, oh, I'm sorry, we don't want to do IT, right? We want to do the current in the phasor notation. So we are looking at I. Okay, and maybe just for completeness, we write V equal to this. Okay, so but to find out I, the first thing that we said we'll do is find out the impedance on the right hand side of this line. So how do we find the impedance here? Now we can see that this capacitor is in series with this resistor. So the impedance of this branch becomes what? The impedance of the branch becomes, so the impedance of the circuit on this side becomes 1 minus j 2 kilo ohms. Okay, like I can just write kilo ohms here, and that is in parallel with this impedance here, and we can calculate the parallel the equivalent resistance there, right? So what is the equivalent resistance going to be? So your Z equivalent, and I'm just going to write this as Z equivalent equal to 1.5 plus, you have this capacitance, this j kilo ohms, and you have this total impedance. These two are in parallel, So when you have impedances in parallel, you do J times 1 minus 2J divided by J plus 1 minus 2J, right? And you can evaluate this, and what does this become? This becomes 1.5 plus you multiply J on the top, you get 2 minus J over 1 minus J. And you can resolve this, I'm sure, because you know complex numbers. You should be able to do this, and you will get 2 plus J 1.5, and this turns out to be 2.5 with an angle of 36.88 oh, let me put my color back, degree kilo ohms. Okay, now that we have found out the Z equivalent, I can find out I quite easily, because I is equal to V divided by Z equivalent, which is equal to 40 angle 90 degrees divided by 2.5 angle 36.87 degrees. And what does that turn out to be? Let me just draw a line to distinguish what I'm writing here from the previous case. And that would turn out to be, well, 16, and the angle is minus 126.87 degrees. Now that we have found out I bar, you can very easily calculate IT, right? So let me just use a different color and write IT here. So what is IT going to be? IT is simply going to be, the amplitude of I is 16 cos, and omega is 3000, so 3000 T, and what's the phase? The phase is this, so minus 126.87 degrees. Okay, and that's your answer, that's your current, and that's quite hopefully that makes sense.